Alright, we're looking at question 3 here. It wants to know which one of those following molecules is the most nonpolar. To answer this correctly, we need to actually have Lewis structures figured out. So I'm getting my valence electrons for each of my atoms. Grand total of 18 valence electrons because 6 plus 6 plus 6. And then 7 times 4 is 28 plus 4 is 32. So I have my valence electrons for each. This one I'm going to put the O in the middle, or the S in the middle, surround it by the oxygens, and just start distributing my electrons on the oxygens. And I get to there, and at 16, 17, 18 electrons. But if I were to do the formal charges right now, I have 6 valence electrons for an oxygen, minus 1, 2, 3, 4, 5, 6, 7. So that's a minus 1, and so is that one because it's the exact same oxygen. And then my sulfur is 6 minus 1, 2, 3, 4, positive 2. And we don't have negatives right next to positives, and I can I can add more bonds to the sulfur because I'm nowhere close to the octet rule. So I'm going to take 2 of the electrons off of that oxygen and share them with the sulfur. That'll get the formal charge on this oxygen to be 0. And sulfur can actually break the octet rule. So I'm going to go ahead and do that again with another pair of electrons. Make a double bond there. And we would have a situation where both those oxygens now has a formal charge of 0. Because we have 6 electrons minus 1, 2 bonds, 3, 4, 5, 6 for our lone electrons. And the sulfur is also 0 because we have 6 valence electrons minus 1, 2, 3, 4, 5, 6. So that is an acceptable structure. If I wanted to draw it now nice and pretty because I can tell what it is, my sulfur has 3 bonding groups coming off of it. So I have those 120-degree bond angles, or at least that's the family we're in. Going to need sp2 hybridization. Bond angles are going to be a little bit less than 120, and it is a bent structure. Alright, now we're going to do the carbon tetrachloride. I'm going to put the carbon in the middle and surround it with chlorines. That takes care of 8 of my electrons. 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. And we've run out of electrons. And formal charges are going to be 0 because I have each of those chlorines comes with 7 valence electrons, minus 1, 2, 3, 4, 5, 6, 7. So they're all 0. And the carbon has got 4 bonds. And a carbon with 4 bonds has a formal charge of 0. I'll write the formal charges there. Now I'm not going to redraw this one because this would involve all those wedges and such. But we do know it is going to be tetrahedral in shape. Because that's what 4 bonds are. About 109.5. And actually this one's not about, since those are exactly the same thing, all 4 of them. These bond angles are exactly 109.5, and it does involve sp3 hybridization. We want to know most nonpolar. The sulfur dioxide, having a bent structure, is going to be polar. All bent molecules are. Tetrahedrals might not be. This tetrahedral has 4 of the exact same things. This thing is totally nonpolar. So that would definitely make it the most nonpolar of those 2.